examples 7 and 8 are very similar to examples 4, 5, and 6 in that we are given a function and we have to find its inverse, and we also have to state the domain and range of both f and f inverse. The only differences between examples 7 and 8 and examples 4, 5, and 6 is that we are not doing the graphical component. We are not going to graph f and f inverse on the same grid. And the other big difference is that your original function in example 7 and 8 is going to be a fraction. So that can get tricky. Okay, so let's take a look at example 7. Okay, we are given f of x is equal to 1 over x minus 1, and we want to find f inverse and then give the domain and range of both f and f inverse. Okay. All right, so before I find the inverse, I'm actually going to take a minute and find the domain of the original function. Okay, so if I look at my original function, it is a fraction, so think back to domain and how you deal with fractions. Okay, remember, domain is everything you are allowed to plug in for x. And when we're dealing with fractions, we think about bad spots. What gets me in trouble? Okay, so I'm going to come up here and I'm going to find my bad spot. With fractions, you cannot divide by 0. Okay, so remember what we did. We took the bottom to find our bad spot. You take the denominator and set it equal to 0. Okay, so what makes that bottom equal to 0? And that's your bad spot. Okay, so if we solve this, we get that x equals 1 is our bad spot. And you can see that by just going back and plugging in x equals 1. You would get 1 divided by 0. That's bad because you can't divide by 0. Okay, so the domain is going to be all real numbers. You can plug in anything you want except for 1. Okay, so remember what we did. We would draw a number line, okay, to track the good x values. 1 is our bad spot, so we're going to put an open circle there. Then everything else is okay. Okay, so my domain of my original function is going to be from negative infinity to 1. We have to get rid of 1 with a parentheses, then pick up on the other side of 1 and go off to infinity. Okay, so that's the domain of the original. All right, so now let's start working on finding the inverse function. Okay, same protocol here. I'm going to start by changing f of x to y. Okay, so I get y equals 1 over x minus 1. Okay, and then in the next step, you need to switch x and y. Okay, so I am going to get that x equals 1 over y minus 1. Okay, you've got to solve this for y now. And that seems a little intimidating because this is a fraction. Okay, what it means to solve for y, okay, let me make this clear from the get-go, okay, is to make this guy look like y equals something, and that something can only have x's, okay? You can't have a y on the right side. So that's what we need this guy to look like, okay? We need to get y by itself, okay? So this is how you should do this if you are given a function that is a fraction, okay? We are going to get rid of the fraction, okay? And this is how we're going to do it. I'm going to write this again so we don't confuse the two steps here, okay? We are going to multiply both sides by this denominator, okay? Because we are dividing by y minus 1, and to undo that, we are going to multiply by y minus 1, okay? And then whatever you do to one side, you have to do to the other, okay? So we're multiplying both sides by this denominator, okay? All right, now remember, y minus 1 is a package deal, okay? So you're going to need parentheses here. You're multiplying by that whole thing, okay? Notice, you don't have any fractions over here, okay? Here you still have the fractions. We'll get rid of them in a second, okay? So if you want to make this a fraction, put it over 1, you can, okay? So in the next step, let's write what's going on, okay? So over here, remember, you can multiply in either order. 3 times 4 is the same thing as 4 times 3. I'm just going to switch the order. You don't have to. We're going to get x times y minus 1. Y minus 1 has to be in parentheses, okay? On the right side, you are multiplying two fractions. Remember how you multiply fractions. You multiply across the top and across the bottom. So you're going to get y minus 1 divided by y minus 1, because anything times 1 is itself, Okay. All right. In the next step, let's look at this right side. Okay. I have y minus 1 divided by y minus 1. Anything divided by itself is 1. Okay. Think about if you just had a number. 4 divided by 4 is 1. Anytime you divide something by itself, it's 1. Okay. And that's what I was saying over here. If you multiplied the by y minus 1 over here, you'd have 1 in the top and 1 in the bottom, and they would cancel, and they're going to leave you with 1. Okay? All right. Our goal is still to solve for y. So what do? Okay? Y is stuck in the parentheses with the minus 1, and then all of that is multiplied by x. Your gut instinct might be to distribute, and that is exactly what you do. Okay? We're going to distribute here to get x times y minus x is equal to 1. Okay? And that might actually look a little messier than what we had before. Okay? But it's going to help us. Okay? When you look at this, this is the only piece that has the y. That's what we're trying to solve for. So we're going to isolate it. Okay? So I'm going to end up adding x to both sides. That is going to tell me that x times y is equal to x plus 1. And now if I want to get y by itself, since I'm multiplying y by x, I'm going to do the opposite and divide by x. Okay, x divided by x, those will cancel, leave me with y. And so y is equal to x plus 1 over x. Okay, and now it's solved for y because I have y equals something, and that something does not contain any y's. Okay, so this is our inverse function. Okay, so let me rewrite it. The inverse function is this, x plus 1 over x. Okay, you can go a step further if you wish and break down this fraction. So you could take everything in the top and divide by x. So you can do x divided by x plus 1 divided by x to get 1. X divided by x is 1 plus 1 over x. This is another way you can write the inverse function. They look different, but they are equivalent. Okay, so I would accept either answer. Okay. All right, so since we formed this inverse function now, I'm going to go ahead and write down its domain. Okay, what am I allowed to plug in for x for this guy? Okay, again, you have a fraction, so you have to worry about the bad spots. Okay, so I'm going to come down here. Okay, so my bad spots for the inverse function, I get that by setting the bottom equal to 0. Take the bottom, set it equal to 0, and solve. It's already solved. So your bad spot is 0. And you can look at that. If I plug in 0, I'm going to divide by 0. That's bad. Okay. So again, my domain is going to be all real numbers except for 0. So if you draw your little picture, 0 is a bad spot. So put an open circle. Everything else is good. So my domain is going to be from negative infinity, throw out the 0 with a parentheses, pick up on the other side of 0, go off to infinity. That is the domain of the inverse. Okay? So now we just need to get the range. And you may be wondering, how do I get that? Because in the past, I've told you 1,000 times, you always have to get the range from a picture, and we're not doing the graphical component. Okay, so you might be rushing to put all this stuff in your calculator. You don't have to. Okay, we don't even need the picture. Okay, we know from our discussion on the relationship between a function and its inverse that the domain of the original function is the same as the range of the inverse. Okay, so these two guys have to be the same thing. Okay, so the range of the inverse is going to be all real numbers except for 1. And also, we know that the range of f has to be equivalent to the domain of f inverse. So these two have to match. So the range of the original function is all real numbers except for 0. And that's it. You didn't need the picture. Okay? So that's the end of the problem. We were able to find the inverse function and state the domain and range of both the original and the inverse.